One enigma that modern astronomers are endeavoring to explain to the best of their abilities is the discovery of ancient quasars and galaxies located far away. These celestial bodies are much older than they should be, spanning billions of years. At times, it appears that these ancient galaxies emerged even before the significant event of the Big Bang. The notion that celestial objects could be older than the beginning of the universe is remarkably astonishing, potentially indicating errors in ancient astronomical age measurements or flaws in the currently accepted cosmological models. Recently, Dr. Rajendra Gupta, a theoretical physicist from the University of Ottawa in Canada, has put forward a new concept capable of significantly elucidating this mystery. By amalgamating contemporary physics knowledge with certain outdated ancient hypotheses, which were previously dismissed by the astronomical community several decades ago, Dr. Gupta's research, published in the MN Ras Journal of the Royal Astronomical Society of the United Kingdom, posits that his novel calculations suggest galaxies might actually be as old as 26.7 billion years, twice the age of the presently embraced universe age of 13.787 billion years. If the occurrence of the Big Bang, or the onset of cosmic expansion, transpired before a period known to us more than tens of billions of years ago, it is not surprising that ancient galaxies, presumed to have formed just a few 100 million years after the Big Bang, are found to be much older. In this scenario, Dr. Gupta has employed the tired light hypothesis propounded by Fritz Zwicky, a Swiss astronomer, in 1929. Zwicky employed this hypothesis to expound the phenomenon of redshift, wherein light from distant celestial objects seems to shift towards the red end of the spectrum as it travels farther away from the observer. Zwicky hypothesized that light traversing vast distances would gradually lose energy, resulting in diminished frequency and increased wavelength. However, this explanation failed to garner widespread acceptance from the astrophysics community in the past. Nevertheless, Dr. Gupta's innovative concept contends that while galaxies are as vast and expansive as currently observed, certain factors in interactions or forces between particles can induce occasional alterations in the behavior of particle pairs. He terms this factor the coupling constant, which is unstable and subject to fluctuations over time within the universe, contingent on changes in associated energy levels. This could impact the behavior of light waves emanating from distant sources, causing them to appear increasingly redshifted and dimmed over time. Consequently, this factor could also influence calculations of the universe's age. In addition to Dr. Gupta's theory's capability to elucidate the anomaly of ancient galaxies with unusually old ages, it also addresses the query of why these ancient galaxies appear to be much smaller in size, despite possessing masses akin to modern-day galaxies. The answer lies in the energy dissipation of light waves, leading to momentum loss and affecting observer visibility. Recently, the James Webb Space Telescope, JWST, discovered 4 of the oldest known quasars, which emerged after the Big Bang, approximately 300 million years later. The JWST confirmed the discovery of these ancient quasars, which are more than 13 billion light-years away from Earth, indicating that they originated in an era when the universe was just beginning to expand. These quasars were detected by an international team of astronomers led by Dr. Stéphane Chartres from the Paris Institute of Astrophysics, and their research findings were published in the latest issue of Nature Astronomy. According to Dr. Chartres, these 4 ancient quasars formed during the Rayonization epoch, a period when the universe began to illuminate due to the emergence of the first stars. Analysis of the size of the stars within these ancient quasars revealed that they were relatively small compared to typical stars in modern quasars. However, despite their small size, These ancient quasars exhibited an incredibly high rate of star formation, which is surprising given the early age of the universe. The discovery of these ancient quasars challenges previous predictions about the growth rate of galaxies in the early universe. It suggests that these quasars may have formed much earlier than previously estimated, evolving rapidly within a short period. This rapid growth resulted in them becoming massive galaxies with tens or hundreds of billions of times the mass of the Sun, despite forming just 500 to 700 million years after the Big Bang. Furthermore, the team also discovered a supermassive black hole, the oldest and most distant one ever found, using the JWST. This black hole, with a mass roughly 10 million times that of the Sun, is considered relatively small. Its formation was estimated to occur only 570 million years after the Big Bang, indicating that celestial objects in this era tended to be smaller than those in the current universe. However, despite their smaller size, these ancient celestial objects, including the 6 quasars detected by the JWST, exhibited an unexpectedly rapid growth rate. They consumed matter and emitted radiation resembling quasars found in the present universe, suggesting an unusually high rate of star formation compared to current models of galaxy evolution. Dr. Joel Lehner, a physicist and astronomer from Penn State University who was not involved in the study, commented that the discovery of these massive and rapidly growing galaxies challenges current models of cosmology. It suggests that the early universe may have been filled with stars and galaxies much earlier and more abundantly than previously thought. The research team plans to further confirm their findings by observing the 6 ancient quasars using the JWST to record their spectra across various wavelengths. This data will provide more precise information about the mass and distance of these enigmatic ancient celestial objects, shedding light on their formation and evolution. In conclusion, the discovery of these ancient quasars and the supermassive black hole challenges our understanding of the early universe's evolution. It suggests that the universe may have been much more active and populated with celestial objects than previously envisioned, prompting a re-evaluation of current cosmological models. If you like space stories, you are our friend. Click follow and press the bell so you don't miss any action.